Hello and welcome to this video about drawing Lewis structures. We're going to focus today on two-dimensional structures and covalent structures. You can use Lewis diagrams to show ionic bonding as well, and you can impose the Lewis structures into your three-dimensional diagrams, but we'll look at those both separately in the future. The first thing we need to do when composing Lewis structures for compounds or for molecules is we need to start off with and we need to identify the Lewis symbol for each of the elements. Right, so we're going to split this into three steps. First of all, we're going to get the symbol off the periodic table. Then we are going to identify the valence electrons, this using the group number. And then we're going to add the valence electrons to the symbol. And I'm going to just demonstrate this with a couple of elements. So we're going to look at hydrogen, symbol is H. It has got one valence electron because it is on its own but above group 1, so therefore my symbol would go H, and I'm just going to have a dot or a cross or something to represent that electron. Second example I'm going to do is going to be chlorine, so Cl. Is in group 17, yeah, or we could say group 7 if we're not including the transition metals. It means that it's got 7 valence electrons, which means that it's going to go Cl, and then it's going to have 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, group 17, 7 valence electrons. If we look at oxygen, again, it's in group 16, which means that it has 6 valence electrons. So we're going to have oxygen here. I'm going to use crosses this time. 1, 2, 3, 4, 5, 6. Okay. And then nitrogen. Okay, so this is group 15, which means it has 5. So we're going to have nitrogen here, and we'll have 1, 2, 3, 4, 5. Okay, and that's the first step, is just identifying how many valence electrons there are in the elements that are going to be involved. So now we're going to move on to step 2, which is about the covalent bonds. So I'm going to zoom out a little bit, just lift this up here. Right. Step 2. Is we're going to identify how many electrons that the element needs to complete the octet. So the octet rule, hopefully we know, means that we are aiming to get 8 electrons in the outer shell, in the valence shell. Not all elements will always follow this, however, we can take it as a rule of thumb and use this as our starting point. So if we look at these, hydrogen has 1 but it only needs 1. So I'm going to put N for needs, 1. Chlorine has 7, so it needs 1. Oxygen has got 6, so it needs 2. Oxygen needs 2. And then nitrogen has 5, so it needs 3. And we work off this rule that with a general covalent bond, a covalent bond will exist between 2 non-metal atoms where they will each share 1 electron. So for every one that you want, you will share 1. I say you, the element. Okay, so I'm just going to write this down here. Share 1, get 1 is the general rule. So then we'll go how many it will share. This is going to share 1. Chlorine will share 1. Oxygen will share up to 2, and nitrogen will share up to 3. Okay, and this is going to help us identify sort of how many bonds we should have around each thing, and maybe start orienting them or putting them together. Right, so we're going to move on to step 3, which is now going to be sort of the final step, I suppose, which is constructing our sort of Lewis structures. Okay, so construct our Lewis structures by combining the elements together. So I'm going to just starting off with the formula of a couple. I'm going to start with something quite simple. So I'm going to start off with Cl2. Cl2. So now I've got two chlorines. Each one needs one, and each one can share one. So I will draw my two chlorine atoms. I'm going to do these in two separate colours. So I'm going to do one in red, like this. I'm going to do the other one in blue here. You'll notice that I'm lining up the single electrons. I'm ignoring the paired electrons I've put on the outside. And so essentially we're adding these two things together. And what that means is what we're going to end up with is this chlorine here, and this chlorine here, and any dots that are in the middle, like this, these are being shared. Now, since there's only one pair, it means I've got a single covalent bond. Okay, and so with a diatomic molecule, this is quite simple. I'm going to do this again for oxygen, so we'll go O2. If I sketch them out, I've got 1, 2, 3, 4, 5, 6. And then I've got 1, 2, 3, 4, 5, 6. This time I don't have any single electrons like I did before in the middle here. Now, if we look back at our table that was up at the top, and it shows us that oxygen has 2 and it will share 2. So 2 of these electrons are going to be shared into the middle. So what I might actually do is just rub out 2 of the electrons from each like that, and I'm just going to place them into the center here. So actually I'm going to put 2 between them, because I want to know how many are being shared, and this is a good way to think about it, is we're going to put our shared electrons between the 2 elements, or between the 2 atoms. So then I'll finish off with, and I've got my oxygen, I'll put my shared ones first, so 1, 2. I'll put my other oxygen over here, 1, 2. So there's my shared electrons in the middle here, and you'll notice I've got 4. So this one is a double bond. But then I also can't forget about all the rest of my valence electrons, so I've got to put them on. I've got 6 in total for oxygen, so I've got 2 red ones here, so I have another 2 here, another 2 here. Same thing here with the blue one, 2 more there, 2 more there. Now what's quite interesting actually is I could also draw this, just another way of representing this. So I'll do this so we can separate off and we can see that it's just the side. Would be using that bar to represent the pair of electrons. So the shared pairs of electrons I'm going to put with the bars in between the 2 atoms like that. So I've got 2 bonded pairs and they're acting between the 2. The pairs that are on their own that aren't bonded, I can just draw as a bar just on the outside of the atom like this. And the same thing here. Now I find this one a little bit more confusing, so I would start off with dots and crosses and then move on to bars when you're a little bit more comfortable. Okay, so we're going to construct the Lewis structures, and I'm just going to modify this by saying that we're going to put in the shared electrons first, and then after you've done that, add the remaining electrons afterwards. Okay, and this is just going to be encompassed within constructing this. So I'm going to do one more. I'm going to do H2O. So I'm going to scroll up, and we're going to do H2O. So I've got 2 hydrogens. Got one here. It's got 1 dot. It's going to share 1. I'm going to have my oxygen here. And I'm going to put my other hydrogen for the moment on the other side like this. Okay, now the hydrogens have each got 1, so they're going to share. That means they're going to get 1 back from the oxygen. Now we said oxygen can share 2, so there's 1 shared and there's a second shared on each of those 2 bonds. So that's all of my shared electrons done. Hydrogen has no more electrons, so there's nothing else to add there, but oxygen still has another 4 valence electrons. So I'm just going to put them in. In the moment I'm going to put them above and below. I'm going to change that slightly in a second. And this is actually the final Lewis structure here. Now, if I wanted to make this a little bit neater, what I might do is I might put the lone pairs, the pairs that are not bonded, next to each other, like this. And then I can put the two hydrogens just slightly below, like this, and just slightly below, like this. Okay. And that's just a slightly different way of drawing out. It gives me a slightly better idea of the shape. But the key thing being that we write out our atoms. We then do our shared electrons first, which are these ones here and these ones here. After we've done that, so that's step one. After we've done that, we then do our lone electrons here, and that's the second part. And that's going to make sure I've got all of my valence electrons done. If you want to self-check, the next thing you can do is just count all of the electrons you've drawn, okay, on the molecule, and this should equal the sum of the valence electrons of the atoms. Hopefully you find that quite useful, and you can have a look through applying that in your lessons.